In this video, I'm going to go over your Geometry 7.2 notes, and we're going to be talking about measuring angles and arcs on circles. A central angle of a circle is an angle with the vertex at the center and whose sides are radii. So in this picture here, we have three central angles. The center must be on the center of the circle. And then if you add 1 plus 2 plus 3, the sum of all central angles is 360. So we can use that in problems like this. So here what I'm going to do, I know that all of these angles added up equal 360. So I'm going to add 105 plus 60 plus 115, which gives me 280. So what's remaining here is going to be 360 minus 280. Which is 80. So you go ahead and try the next one. So for that, we add 120 and 90. That notation tells me 90. That gives me 210. 360 minus 210 is 150. Next, an arc is a portion of the circle defined by two endpoints. So it's around the circle, a certain measure. We have three different types of arcs. Actually, the measure of the arc is equal to the measure of the central angle. So whatever the central angle is, we consider the arc that is cut off by that to be the same thing. If the angle is less than 180, so this angle is less than 180, so this arc would be less than 180. We call that a minor arc. Okay, the naming is going to be kind of like a segment, but instead of a segment symbol on top of it, we will use an arc symbol. On a circle, we can connect 2 points two directions. I can go the short distance, which would be the minor arc, or I can go the long way around. Okay, this is called a major arc. Okay, if you see just two letters, then it is implied that it is the minor arc, that you're going the shortest distance. So if I wanted to say they have the same endpoints, A, B, but to indicate that I'm going around this direction, I have to include some other point. So this is going to be A, D, B. The D tells me I need to pass through D to get there. Last type is if it equals 180, then it is a semicircle. And again, we have to indicate direction, because if I have AB, I don't know if I'm going this direction or this direction. So this would again be arc ADB. All right, so in this diagram, BD and AC are diameters. We're going to identify the arc as major, minor, or semicircle, and then we're going to find its measure. So BA is this arc right here. So the measure is less than 180, so this is a minor arc, and its measure will be 44. ACB means we're going all the way around this circle. So that is a major arc, and its measure is going to be 360 minus 44, which is 316. So you go ahead and try these two. BCD is 180 degrees, so it is a semicircle. AD, always the shortest distance if there's two letters, is going to be this. So I do 180 minus 44, which is 136. And that's less than 180, so it is a minor arc. Okay, use addition and subtraction to find the measure of the arc. So we want DEA. So that's going to be 120 plus 90, which is 210. So you try finding this one. For this one, BEA is going to be this thing here. If this is 90, this is 90. So to find it, we do 360 minus 90, which is 270. We can talk about the measure of the arc, which is going to equal the measure of the central angle versus arc length, which is actually the physical distance that you would have to go. Well, if we want to know the actual distance, then we need to know how big the triangle is based on its radius. So the formula for the arc length is x over 360 times the circumference, so times 2 pi r, where x is the central angle and r is the radius. Okay, so in example 5 here, I want to find the length of arc AB. So that's going to be 135 divided by 360 and then multiplied by 2 pi times 8. We will get 18.8 inches for that. Okay, let's do another one. We're going to find RT if MT is 7. Well, MT is the diameter, so that means my radius is 3.5. So the measure of our arc, the measure would be 50. The arc length is 50 divided by 360 times 2 pi 3.5, which is 3.1, and this would be in yards. So you try the next two. Okay, for these last two problems, the central angle is 45. If BE, which is the diameter, is 24, then the radius is 12. So we plug that in to get 9.4. This one, we want to find SR, so the central angle there is going to be 100. PS is a radius of 10, so we get 17.5. So that is arcs and their arc length.